you might want to know like what your mile per gallon is, and your car may not tell you that. So that's something that sometimes you want to know what your gas mileage is. So that's what number 21 is talking about. Like, what is your gas mileage? How efficient is your vehicle? And I know for sure mine calculates it for me, which is nice because I can kind of see that number every once in a while. You want to know how you're doing with gas mileage. So this says on Friday you left for a weekend camping trip and there were 110 miles on your odometer. And your gas tank had 14.5 gallons of gas in it. When you returned on Sunday, your odometer read 299 miles and you still had 7.5 gallons left in the tank. So there is a trip feature on a car that, like, each time you refuel with gas, I reset my trip feature so it goes down to 0. So this would be looking at that like I have 110 miles currently on this tank of gas that I filled up at some time, and I have 14.5 gallons of gas in the tank. And then after I've driven, I now have 299 miles and I still have 7.5 gallons of gas left in the tank. So our goal is to figure out the fuel efficiency of the trip. So when you're talking about fuel efficiency, it's usually looked at as miles, I missed an E, per gallon. So when we're talking about slope we know is the rise on top and the run on the bottom. But when we're trying to compare that to a word problem, with a word problem, we can't really think of it as being a rise over run because we're talking about miles and gallons. So when we try and come up with our equation for slope, we're going to try and write a fraction that consists of the miles being on top versus the gallons being on the bottom. And that's because that's the way you measure fuel efficiency. So when you're talking about fuel efficiency, it's always measured in miles per gallon, not gallons per mile. So how many miles did you get for each gallon of gas? So saying that, can anybody come up with a fraction or numbers to put in the slope formula? So this isn't an equation, this is a formula. So we're still calculating fuel efficiency, or really we're calculating slope. Jaden, what do you think?
So on the top, I put 299 minus 110. And then, do you want me to keep going with the bottom?
Yeah, you're good. Yep, keep going.
Okay. And then on the bottom, I did 7.5 minus 14.5. And I did absolute value because even though you're taking away, it's going to be positive because you can't use negative miles of gas, I think it was,
Yeah.
or gallons of gas. So
right. No,
I
that
did
makes
absolute
sense.
value.
Yeah, that's a good explanation. So just kind of looking at what she is talking about here. So noticing that you have a Y value of 299, or your odometer read 299 when your trip was complete. That's your second Y value. So I could write that as 299 as a Y value if I wanted to write it as an ordered pair. And at that value, I had 7.5 miles of gas, or I'm sorry, 7.5 gallons of gas in my tank. So that's our end result, which represents Y2 as our end result. We began with 110 miles, so I could call that Y1 because that's how much I started with. And I started with 14.5 gallons in my tank. So if you wanted to think of it as ordered pairs and try and associate it with X and Y, this is the way that you could do that. The other way to think about it is as Jordan explained. So you're taking the miles and you're subtracting them. And it's that second mile minus the first. And then again, you have to make sure you're kind of organizing your data so that they go together. So vertically, 299 goes with the 7.5 because that's how many gallons I had left. So Jaden, I'm sorry. If you subtract those, what did you get on the top?
I got 189.
And then on the bottom?
I got 7. Well, it comes out to -7,
right.
but I put
yes.
7.
Correct, yeah. So it would come out to be -7. But we know that gas, the amount of gas that you have can't be negative. But there is a reason this number is negative. And that's because you're losing gas as you drive. You're using it. So you started with one number of 14.5. Well, the further you drive, the less gas you have in your tank. So that is why it's negative. But in theory, as Jaden said, it can't really be negative because I don't have a negative amount of gas in my tank. It's just negative to represent the facts that we're actually losing gas. So the negative only represents the fact that you lost gas in your tank, but you would not keep it as a negative value. So Jaden, if you divide these two numbers, you said you kind of like took the absolute value of this, since we really are talking about a tangible thing, it has to be positive. What did you get then for your miles per gallon or your fuel efficiency?
I got 27 miles over gallons. So
Yeah.
27, yeah.
So our fuel efficiency would be 27 miles per gallon. So again, fuel efficiency, and I know a lot of you are ninth graders, so you're not quite there to trying to get your permit yet. 10th graders, you are probably this year going to get your permit. But fuel efficiency, like 27 miles per gallon is pretty good. I definitely don't get that, but I have a big SUV. And I'm usually happy when I get about 22. Typically, it's about 17. So the smaller your vehicle that you drive, usually the better mile per gallon of gas that you get, or fuel efficiency that you would get. I know you have a smaller SUV than I have.
I get about 20.
Okay, so that's not bad. But this car must be a little smaller. I mean, they're on a road trip, you usually get better gas mileage, like traveling on the turnpike or traveling on a highway at a consistent speed usually gets you better gas mileage than just a stop and go kind of thing. Like traveling down McKnight Road is never good for gas mileage because you're stopping at all of those red lights. Your car never gets like the energy it needs to kind of sustain a nice mile per gallon. Any questions on 21? So if you look at 22, this one's talking about a production rate. And this one here, you're working and you start at 7 o'clock and you're making steel valves. And we have at 7 o'clock, there's 100 steel valves that have already been made or machined. And then it says, or that are ready for assembly. At 3 o'clock, your shift is done. And there are now 424 steel valves that were completed and ready for assembly. So sometime overnight, somebody already put 120 of them together. You come in at 7 o'clock, 120 of them are already complete. You leave at 3 o'clock, and now 424 of them are complete. It says the target production rate is 36 steel valves per hour. What is your production rate? And then would your supervisor be satisfied with your work pace? So there's a couple of things that we have to think about here. So when we're again talking about a rate, so we had miles per gallon, that helped us figure out the type of fraction that we want to come up with. So for this one, for 22, we are making steel valves, and the time that we're talking about is in hours. So a rate is something per something, miles per gallon. Or in this case, the valves per hour. So that might help you kind of think about what goes on the top of the fraction, what goes on the bottom. Because a lot of questions said, or a lot of people said, I had my fraction flipped. Well, your fraction was probably flipped because you didn't have the production rate written correctly or the efficiency rate written correctly. So think about real life situation. How is time measured, or how would be miles per gallon measured? So time usually is the bottom value because that's our independent value. So as time passes, I should be able to produce more valves. So anything that's independent goes on the bottom because that is always our x. So thinking about it as y over x. So if you reread that problem, read through it again, can somebody try and set up a formula thinking about valves per hour? So how could I take the numbers from this word problem and try and plug it into the fraction for slope? Ava.
Okay, so what I did was I did 120 minus 424.
Okay.
And then on the bottom, I counted the hours. So you start with 1 hour and then you count like 7 to 8, 8 to 9. And that was 9 hours.
Okay, so you started with the first hour and then you counted up and you said you ended with the 9th hour. So you treated 7 o'clock as hour 1 and then 3 o'clock as hour 9. Is that what you said? Yeah. Okay, perfect. Yeah. Okay. So she's organizing this as thinking my first hour that I'm there, there's 120 valves per minute. The last hour, or hour 9, because she treated 7 o'clock as a 1, and then if you just count up to 3, then you're at 9. That corresponds with the valves per hour. Another way you could have thought about it, and I'm going to keep it pretty much the same, is you could have also said that 7 o'clock would be your initial hour or hour 0, because I haven't worked yet. It's 7 o'clock, I just got on the job, so no hours have passed. And if I, again, count exactly as she said, I would count, and I worked 8 hours. So 3 o'clock would be my 8th hour. Notice that you're going to get the same number on the denominator. So it just depends on how you're thinking about it and what you're assigning 7 o'clock to be. So she assigned it to be a 1 for her first hour and then just counted up to 3 and ended up with the value of 9. So you're assigning numbers to represent time. So Ava, when you subtracted those, I know I get a -8 on the bottom. What number is on the top when we take 120 minus 424?
-304.
And then when you divide, you end up with a slope of?
+38.
Right, so 38, and then we're talking about valves per hour. So the key thing with using slope is to make sure your fractions and the numbers are lining up. So whatever you write first has to correspond with the number underneath in the denominator. So when you started, there were 120 valves on the machine that were made already. So you need to make sure that 120 is corresponding with a starting value. So whether you use a starting value of 0 or a starting value of 1, that 120 needs to correspond with it directly underneath. And then when it ended, there are now 424 valves, and we worked 8 hours. So if I start at 1, I'm now at 9 because 8 hours have passed, or if I started at 0, we're now at 8 because 8 hours have passed. You could have had this fraction flipped, and you could have said 424 minus 120, and then 8 minus 0 as well. Any of these ways are correct. So you're still getting the same answer, it just depends on what you're thinking about. But the key fact is that we have to talk about valves per hour. The number of valves are dependent upon how many hours I work, and that's why the hours goes in the denominator. And that was a key thing that a lot of students had questions on. Like a lot of you had it flipped, and the reason you had it flipped is you probably had the hours on the top. But valves depend on hours worked. So try and think when you're looking at a word problem, what would be the independent value? That goes in the denominator. Questions? Are there questions on 21? So today we're going to use slope to graph lines in slope-intercept form, and we'll see that the slope is truly the movement of the line, the steepness of the line. So how does the line move? Does it move up? Does it move down? How steep is that line? So that's what we're going to look at today. Hopefully this is a nice, easy Friday review. We're going to review x and y intercepts. That might not be quite as easy of a review as slope-intercept form, but you'll see that they're fairly straightforward to find and calculate. So in your packet for Chapter 2, we're looking at Section 2.3. And just as a little side note, I was doing the agenda for next week last night, and right now it's looking like on the agenda that we will have a quiz, I won't say a test, a quiz on Thursday of next week. So we're going to go over Section 2.4 on Monday. On Tuesday, we're going to finish 2.4 and do 2.5. 2.5 is just a short little section. And then Wednesday, we'll probably review for a quiz on Thursday. So just so you're looking ahead, that agenda will be posted later today. But it's looking like there should be a quiz on the first half of this chapter next Thursday. And then the second half, I would say, is probably more new material than it would be review, and we'll definitely spend more time on the second half. So there are only 2 sections, 2.6 and 2.7, for us to cover in the second half of the chapter, but those 2 sections will probably take us 6 class days, or maybe even 7 class days. So thinking about that is kind of more spread out than what we've been doing so far. We've been kind of rolling at a section a day, a pretty good clip. So looking at section 2.3, we're graphing equations of lines, which we graphed a little bit on Wednesday with the T-chart. Well, we're done with the T-chart. We kind of recognized how X and Y are related, and now we're going to graph this in that slope-intercept form. But the first word we have, and we're going to look at this word in every single chapter that we talk about. So, except chapter 3. But chapters 4 through 8, we'll be talking about a parent function versus the regular function. So a parent function is the most basic function. For a family of functions. So, did you know functions could have families? Pretty much each different graph that we talk about is considered a family. So, my family is different than your family. So, one function that we talk about is going to be different than another family. The parent function is the most basic. So, think of it as like the head of the family, and then from that, I have 2 kids, and they are different, they change. So the same thing with a graph. We have a basic graph, but once we start adding numbers to it, they get different and they change. But the parent function is the basic function. And we will look at a basic function for each type of equation that we approach this year, and then we'll expand on it. So the basic one should be the easy one to graph. And then once we expand, it's going to get a little more interesting. So for a linear function, the parent function, again, the most basic function, is of the form y equals x. So we're talking about linear. So that means it doesn't have a slope other than 1, and the y-intercept is back here, and that is 0. So it's the most basic. The slope is 1. It crosses through the origin. It has a y-intercept of 0. So this is our basic function. Looking at the graph that's provided, again, you can see it has a y-intercept at the origin, or at 0, and its slope, its rise over run, is 1. So the steepness compared to the run is the same. So that's considered a basic function. It doesn't have any extra numbers added to it. Below this, it says, in general, a y value of the graph, or we'll say a y-intercept of the graph, is the y-coordinate of a point where the graph intersects the y-axis. So there are important pieces of graphs. One would be the steepness of the graph, or the steepness of the curve. The other part is where is it crossing the y-axis. Those are 2 important parts of the graph. There's a third part that would be where is it crossing the x-axis, and we'll talk about that later as well. But a y-intercept is the y-coordinate of a point where the graph crosses the y-axis. So it's the y value. How about slope-intercept form? Anybody remember what slope-intercept form is? What does it look like? Annabelle, do you remember what slope-intercept form looks like?
Not really.
Not really? Somebody want to help her out? What would slope-intercept form look like? Brooke?
Isn't it y equals mx plus b?
Yeah, and yesterday we were looking at this form, and we called this a linear function. Slope-intercept form is linear. Brooke, do you remember what the M stands for in slope-intercept form?
The slope.
Yeah, so the M is the slope, hence the word slope-intercept form. Brooke, what's the B value?
The B is the y-intercept.
Yep. So mathematicians aren't very original. I mean, we're math people, and I'm totally a math person. I am not very creative. I can use sidewalk chalk and I can draw circles and stars, and I'm really good at drawing pigs and flowers. I like cute little pig that's kind of oval with an oval nose and a squirrely cute tail, curly cute tail, whatever I'm trying to say. But that's about my creativity limit. So math people, slope-intercept form, literally you have the slope and the intercept in the form of the equation. So we're going to graph a slope-intercept form equation by first writing the equation in slope-intercept form. I didn't leave us a lot of room there to write that. Sometimes it might not be in y equals mx plus b form, and we might have to change it so that it's in slope-intercept form. The second thing, we're going to find the y-intercept, or the b value, and use it to plot the point 0, comma b. The reason it's 0, b is because it's on the y-axis when the x value is 0. We're going to identify the slope, which is m, and use it to plot a second point, or a third point, or a fourth point on the line. And then finally, we will create a line through those 2 points, or connect the line through those 2 points. Whatever word you like to use there. Draw the line through those 2 points. So it seems pretty straightforward. Write it in y equals mx plus b form, slope-intercept form, find the y-intercept, identify the slope, make a line. So we're going to see if we can review graphing an equation in slope-intercept form. So thinking about that process again, the first thing, it needs to be in slope-intercept form. Well, this one is y equals mx plus b already. If the y wasn't by itself, then I'd have to get y by itself by solving for y, isolating the y variable. The second thing that we need to do is think about what would be the slope and the y-intercept. Ella, what is the slope and the y-intercept of this equation?
The slope is -3/2, and the y-intercept is +1.
Right. So you could write that +1 as an ordered pair, or you could write b equals 1. Either way, make sure you're identifying what it is. So either write it as 0, 1, because the x value is 0, every y-intercept, or write it as b equals 1. So when you graph, can anybody explain? So if you were trying to teach a 6th grader or a 7th grader how to graph a line, how would you explain that to them? So what would you say to start with? Think about your younger siblings. They might be in middle school right now. Some of you might have some younger siblings. Brooke, how would you explain where to start to graph a line?
I would say start with the y-intercept because that's the easiest point.
Mm-hmm. So you begin with B, the y-intercept.
And
What do you do?
since it's negative, you would go down 3 and over right because the 3 is negative. I mean, you could switch it up, but
Yep, you're right. You could switch it up too, yes. But generally, we make that top number negative, and you keep the bottom number positive. But one
right.
of them has to be negative. Nice job, Brooke. So you begin with B, you move with the slope. The slope is the movement of the line. So she said we move down 3, and then we move right 2. And I get to that point. So if I was teaching somebody to graph a line for the first time, Brooke, you did a great job. I think they would pass their test. I'm going to just do another one, going down 3 and right 2 to get to another value. Connect your points, create a line. Ooh. My line doesn't seem very well connected here. Hopefully your line isn't as squiggly as mine. I tried to make it a straight line the first time and I didn't do a good job connecting, so now I just have a squiggly line. But that's slope-intercept form, as basic as that. Start with the b value, move with the slope, and make a couple of points. And as Brooke said, we could also go the other way. If I had more values on here to plot, I could go the opposite direction and get a point up above my y-intercept if I wanted to as well. Just depends on what kind of graph you're given. So the other way that we can graph a line, so one way, slope-intercept form. The second way is called standard form. Every equation has two different ways to look at it. One is usually considered more graphable than the other. So slope-intercept form is pretty easy to graph because we have an m and a b. Well, standard form can also be pretty easy to graph. And this form is ax plus by equals 0. And as I said, as we work through the year, you will see that we will think of graphs in two different forms. So we'll look at it in its general form, or look at it in its standard form. So we're going to look at it in these two different forms and try and graph it in both forms. So this would be our standard form when it's equal to 0, or actually, you know what, let's put it equal to c, because it doesn't have to be equal to 0. It can be equal to any number over there. We'll place it equal to c. So a, b, and c are just numbers. A and b would be coefficients. C could be any number. So knowing what a y-intercept is, where the graph crosses the y-axis, what would be an x-intercept? So how could you describe or define an x-intercept? Ava.
Would it be the point on like the x-axis?
Yep, perfect. And the way we write that point would be a comma 0. So a y-intercept is 0 comma b, and x-intercept is a comma 0. So we can also graph using standard form, just like we can graph using slope-intercept form. So the first step says write the equation in standard form, and then it says if needed. Essentially, if it's not already written in standard form, I would say don't use standard form. If it's written as y equals mx plus b, then you want to graph it as y equals mx plus b with slope-intercept form. So you're going to kind of identify how is it written, which form do I want to use. The second one, identify the x-intercept by letting the y value equal 0. And that's because an x-intercept crosses the x-axis when y is 0. And then you solve for x. The x-intercept would be the place where the line crosses the graph at a comma 0. Something comma 0, that's what a means, 7, 0, 5, 0, negative 3, 0. Identify the y-intercept by letting x equal 0 and solving for y. So essentially, whatever letter we're solving for is the intercept we're trying to find. So the x-intercept, I'm solving for x. The y-intercept, I'm solving for y. And plot the point where the line crosses, and that would be at 0 comma b, or where it crosses the y-axis. So you could say where it crosses the y-axis, or the point 0b where it crosses the x-axis, or the point a comma 0. And then draw a line through the 2 points. So we're going to see if we can graph this equation. I'm going to make just a little chart to kind of separate and organize the information. We're going to find an x-intercept. I'm abbreviating intercept INT. We're going to graph a y-intercept. So in standard form, you're finding an x and a y-intercept. We're not finding a slope and the b value. So we're trying to get an x and a y-intercept. And the way we do that is by letting y equal 0 for the x, or letting x equal 0 for the y. So try and like organize your thoughts, organize your information. How are we approaching this problem? I just make a little T-chart. So if I want to find an x-intercept, I'm going to take the equation. I want to find x. So that means I'm solving for x by making y 0. So Julia, if I solve for x here, I have 2x plus 3 times 0 equals 12. What does this become? What's x equal to?
6.
Yeah, this cancels, gone. I get 2x equals 12 or x equals 6. Now make sure that you write it correctly. We're solving for an intercept when the y value is 0. So I'm going to take that and make it a point. You will get it marked wrong if it's not written as an intercept. So I wasn't just solving for x, I was finding the x-intercept, which means I plugged a 0 in for y. So if I do the same thing with the one right next door, I want to get the y-intercept, so that means I'm letting x equal 0, and I want to get y. Leah, what would the y value be here?
Four.
Yeah. So pretty easy because you're plugging a 0 in, you're eliminating that other variable, and then you just have a tiny little equation to solve for y. Again, write it as a point, 0, 4. So now we're going to go plot these points. 2 points to plot, and then we connect the dots. So the first one should be on the x-axis. X is 6. Make sure you're graphing 2 separate points. They don't go together and create their own point or to create a slope. It's 2 separate points. One's on the x-axis and the other's on the y-axis. And then connect your line. And that's it. That's graphing in standard form. Does anybody remember doing that? Maybe in Algebra 1? Usually isn't the form that most people graph in. But we'll talk about finding x and y intercepts throughout the year. It's a pretty important concept. Questions? All right, so the very last thing that we're going to look at, just 2 final little graphs. We talked about graphs having a slope and being increasing and decreasing. Well, what happens if we have horizontal and vertical lines? So yesterday, I used the word hoy. And we said a horizontal line had a slope of 0. This y part is how you're supposed to write your equation. My equation is going to be in y equals form. So a horizontal line has a 0 slope. The graph or the equation would be in y equals. And in this case, it says y equals c. It creates a horizontal line through that y value of c. So whatever c is, I'm going up on the y-axis or down on the y-axis, plotting that point, and then making a horizontal line. A vertical line has an undefined slope and is in x equals form. So the slope is undefined. That's why that u is there. So the graph or the equation looks like x equals c. C is for any number, a constant. And it's a vertical line through the point c, 0. So you're going to move over to where your x number is and make a vertical line. So these 2 final little graphs here. The first one says y equals -1. So this means it's y. So I have a horizontal line since it says y. So I'm going to go to where the y is -1. Well, find your y-axis. Go down to -1. That's my point. That's the only point. And then I draw a horizontal line through that point. And that's it, because the slope is 0. It's not rising, it's not falling, it's just horizontal. The final graph says x equals, this is my vertical line because there's an x in the equation. It's an x equals form, and the slope is undefined. So I'm going to go to where x is equal to 2. Literally, it's telling you exactly what you're supposed to do. X is equal to 2. Okay, well, here's x is 2. And then I need to draw a vertical line going through that point of 2. Again, the slope is undefined. It's not moving. It's just a vertical line. So we graphed in 2 different forms today, slope-intercept and standard form, finding the x and the y-intercepts. And then those 2 final problems are just looking at horizontal or vertical lines. Your homework tonight is a little mix of everything. So you have a couple of graph problems for Monday. And then there's also just a couple of problems trying to getting you to practice getting y by itself, so getting slope-intercept form, or getting you to practice finding the x and the y-intercepts. Please make sure you're showing me a little bit of work. So a little bit of work for each problem so I understand that you're thinking about that thought process to get through the equation. Anybody have questions? Have a fantastic weekend. 2 weeks done. Hopefully 3 more to go, and then I see you in person in October. But congrats on almost getting 2 weeks through. Enjoy your weekend. If anyone has questions, feel free to stay on and ask.
Miss Kane.